Okay, today we're going to learn a different form of the equation of a parabola. So it's not vertex form, it's not standard form, it's just a regular, I guess you could call it a conic section form, which you're going to find out in just a minute. So this parabola is found a lot in the real world, and here's some examples of those. And what we're going to be discussing today, so you can see all the parabolas here, of course, on the page, you know, so it's kind of neat. The dolphins, like it's in nature definitely a lot because of the properties that it holds. We're going to be talking more about this type of parabolic shape because of this point right here, which is called a focal point. Okay. And of course, these are my favorite. So the dog's snout, I guess, would be the focal point of this one. And a funny story for you real quick. Our dog Zach had to have one of these on one time, and we were eating pizza, and Jeff took his pizza crust, he calls them pizza bones, and so he's like, you want pizza bones? And the dogs want to come have pizza bones. And so he threw it at Zach, and it landed like right in the corner, right here, like by the back of his head. And he spun around in circles trying to get that pizza bone, and it was so funny. We were laughing so hard we couldn't even help him. It was hilarious. We eventually gave him the pizza bone and more because he had to work for it. All right, so where this equation of a parabola comes from is what's called conic sections. And in college algebra, pre-calc, and higher level math courses, you're actually going to learn about all of the conic sections. And they come from taking a cone and slicing it, kind of like what you see over here, and slicing it with a plane. And so you create different types of sections. So one would be obviously the circle, if you cross that plane through that way. One is the ellipse. The one we're going to learn about is the parabola. All the conic sections used to be in the Algebra 2 standards and the old standards. Now with this new, we only do the parabola for some reason. And then there's a fourth one called the hyperbola, which looks very similar to a parabola, except there's two of them. Okay, so this one right here is the one we're going to focus on. If we took this plane and we sliced it through, I guess it would go kind of like this, through that cone, then we're creating this parabolic shape. And that's the equation that we will be learning about. Okay, so this is kind of how it works and why it's so special. And you can open your workbooks to page 35. You're going to see this picture here on the left. And what's happening is you're going to have a focal point, which is very important that you give. And the reason this works, so this example that you're looking at is for like a flashlight. So we're saying the bulb is here and it's shining light back onto the parabola. And so what happens is as it shines that light, it's bouncing off the parabola and going into direct motion. Same thing here. So that's why, so same thing here. And so that's why it works. This point, called the focal point, is where every beam of light is going to go through, and then it's going to touch the background of that parabola. So that would be like the way that it would be put out, I guess, into whatever you're shining your flashlight at. So a satellite dish, which a lot of you have these on your houses, so if you ever wondered about why this little piece right here is there, it's because that is the focal point. So what happens is your satellite, I don't know what a satellite looks like, I'm imagining a spaceship, but there's a satellite up in space somewhere, and it's sending signals that are bouncing off the back of this parabola onto the focal point. This focal point is what sends it into your TV. So it could come at any different angle, and it's going to bounce off of that. This parabola is made to catch those signals and send them to the focal point. So the focus, whoever engineered this, has to have the focus in the right place. Otherwise, the signal is going to be way off. Okay, so that's kind of how we use that in, you know, in your everyday. I'm sure some of you go home and go straight to the TV, so now you know how parabolas fit into that. On page 36 in your workbook, we're going to go through the way that you're going to set up these equations or how to read them. So we got two different things going on. We have the this type of parabola in this type. So some of you have asked me in class, are parabolas always going to be facing up and down? And my answer to those who asked was no, but that doesn't happen in the equations we've learned so far, because all of them are y equals. When you see this y equals something in terms of x squared, that means it's either going to open up, and it opens up if it's a positive, and this you already know, so this isn't anything new. If your number in front is positive, it opens up. If the number in front is negative, it opens down. Okay, and this P that it has there, this letter P, just stands for the distance. This is the distance from P. Oh, I'm sorry, it's a different distance from the vertex to the focus and the vertex to the directrix. And the directrix is just a line behind the parabola that offsets the focus. Okay, so they're equidistant from the vertex, so that would be your P. So if you look at these things, I don't want you to memorize these. I don't want you to even really try to use them in any way the way they're written here. I want you to do everything through drawing. So I'm going to show you a couple of examples in a minute. Alright, so when it starts with y equals, that's when it opens up or down. So of course it would naturally make sense that when it starts with x equals, that means my function is a term of y squared. So I'm going to have it opening either to the right, which would make sense when it's positive, or to the left, which would be when it's negative. Again, that should make sense. Positive opens to the positive numbers on the number line. Negative opens to the negative numbers on the number line. So that should make sense. Now notice where the focus is though. The focus is always on the inside of the parabola. The directrix is always on the outside of the parabola. So notice how they're written here. Okay, again, I don't want you to necessarily know these. I want you to just find them. So on the next page we'll do some examples that will explain that. All right, so here are your two examples. And I'm going to ask you for, usually I'll ask you for the vertex, I'll ask you for the focus, and I'll ask you for the directrix. Okay, so in order to do that, you have to be able to find what P is. All right, so in this case, the origin, we'll talk about later, the vertex is going to be at 0, 0, and that's because there's no number with this y and there's no number with this x. The next segment will teach you how to find it if it's not at the origin. So the vertex is going to be at 0, 0. Okay, so we're going to start there. And I also need to know the direction. So the direction we get from what it starts with, which is y equals. So since it's y equals and then 1 over 4p is negative, that means it's going to face down. Okay, so we're just going to draw a random down parabola, and I know this goes against what I talked about with the other ones, but this is perfectly fine for this particular equation setup. All right, so the next thing we need to be able to do is, remember, we're still trying to get to the focus and the directrix. So I need the direction, and then I need P. Now remember, P is, in the setup, it's 1 over 4P. So if ours is negative 1 over 16, then it has to be that P is, well, technically it would be negative 4, but we just look at it as a distance, so we're just going to use positive 4. So what I'm going to do is make sure my focus is inside of the parabola. So that means I have to go inside 4 and put a point. That's my focus. And I have to go outside 4 and draw a line, and that is my directrix. Okay, so now I can just label these points. That's why I don't want you to memorize what was on the other page. I just want you to find it. So the focus would be at 0, negative 4. Okay, because I can list that point. And the directrix is the horizontal line. Notice the y equals 4. Okay, so let's try another one. We'll do this one here in black. All right, so again, I want all the pieces. I want the vertex, I want the focus, and I want the directrix. Now in this case though, it's going to start with x equals. So that tells me for the direction, you always want to think about that. Oh, sorry, let's start with the vertex. Vertex is 0, 0. Okay, so for the direction, since it starts with x equals, that means it's either going to be left or right. The way that I choose is depending on whether this number is positive or negative. Since that's positive, it's going to open up to the right. So I'm going to take my vertex and I'm just going to open a random parabola to the right. Okay, now we have to be able to find p. Again, p is if it's 1 over 4p in the equation, and our specific example is 1 over 8, then p has to be 2. So I'm going to go 2 inside the parabola for the focus, 2 outside the parabola for the directrix. Okay, so the focus then is going to be at the point, and again we'll just read it off, so it'll be at the point 2, 0, and the directrix will be at the line x equals, because it's a vertical line, -2. Okay, and this is on page 37, numbers 1 and 2 at the bottom. Once you're able to understand the concept of graphing, and with just those 3 pieces, you should be able to create equations. Now we're not going to use the distance formula, we're just going to use our basic knowledge of a parabola. Okay, so if this tells me if the focus is at 0, -8, well, how many is that? 1, 2, 3, 4, 5, 6, 7, 8. 0, -8 is my focus. My directrix is at the line y equals 8. Okay, then that means my parabola, the vertex first of all has to be at 0, 0, but my parabola has to open down because my focus is down here. So when I write that, I just want to keep into consideration that's opening down, which would start with y equals negative. Okay, y equals because it's up or down, and negative because it's down. And then we're going to do 1 over 4 times p. Now p, remember, is the distance from the vertex to the focus or the vertex to the directrix. So that happens to be 8. Okay, and then we can't forget this is in terms of x squared. So the final answer would be, okay, and that's it. That's all I'm asking you to do for right now. All right, so let's try another way. This one says I have a vertex at 0, 0, and I have my focus at 0, 1. That's my focus. Well, if that's my focus, then it tells me that it should be opening up. Okay, so again, I'm looking at y equals, this time it's going to be a positive. My p is going to be 1, so 1 over 4 times 1, which is just 4, x squared. And then that one was pretty easy to do. Okay, feel free to back up and watch these 2 examples again if you need to. Okay, now we're doing the same exact thing, except we have a vertex off the origin at HK. So here's the setup for, again, an up and down parabola. How do I know that? Because it's y equals. Notice that 4p, 1 over 4p is the same thing. The difference is going to be this HK. Now luckily you already know that from your previous knowledge of parabolas. So you should be able to find the center very easy. I'm sorry, the vertex very easy. Okay, so we grab it from here. The vertex, you start at HK. P, still find the same way, so you either go inside the parabola, either way, and the directrix is P on the outside of the parabola. Either way, it just depends on how it's written. Same thing here. You still find HK the same, except notice that H is there, K is there. That's because the y value, K is going to go with the y value in the original function. Okay. So again, once you determine that it's left and right because it's the x-axis, left and right, then you're going to go inside and outside P, and then you should be able to graph the problem. So let's try some. Oh, I'm sorry, let's try one. Okay, so we have a couple of things again. We want the vertex, we want the focus, and we want the directrix. So the vertex in this case, since it says x equals, that means this is my, oh, this should be a y. Sorry, let's change that real quick. That should be a y. That means that this is my y value, this is my x value. So when I write my vertex, I want it to be the x first, which is 1, and then 2 will be my y value. Okay, so this will be at 1, 2. I know because it's x equals a negative, I know it's going to open up left. So I'm going to go ahead and show that part. It's going to open to the left. All right. We need P next in order to find the focus. So if the 1 over 4P is negative 1 over 8, then P has to be 2. Technically it's negative 2, but a distance is never negative. So we're going to go inside 2, outside 2. Okay, so here's my focus and my directrix. Alright, so then when I label that, it's probably better on graph paper. This will be negative 1, 2, and the directrix will be at the line x equals 3.